In this video, we are going to look at SF and DP, also known as significant figures and decimal places. Okay, so if you are doing kind of paper 3, you need to know at least some conventions about significant figures and decimal places. So that's what we're going to look at. Two things today: conventions for most of them and a very special case. So stay tuned or hop to the end if you want to know about the special case coming up. So the first rule of thumb is you need to follow paper 3 convention. Don't forget your AS. What you remember from AS, you use it. So in AS, we have what we call the raw value, and you do some magic to it, calculation. And you have a calculated value. So if your raw value has, for example, 3 SF, your calculated value should be 3 or plus 1, same or plus 1, so 3 or 4 SF. Or if you have, I don't know, 2 SF, then this can be 2 or 3. Same or plus 1. So let's look at an example how to apply this understanding of raw transform into a calculated value. The first example is one of the past year. You can see where it's from, ON18, Winter 18, paper 5. So this question, you look very carefully. What are we trying to calculate? They'll give you a blank space and you have to do some calculation. So this is what we call a calculated value. What are we calculating it from? Look carefully. V. Oh, so we are calculating 1 over V from this one. So you have to think about how you're going to calculate this. How do you know if it's calculated value or not? You press calculator. So you have a calculator that will appear, or in your room. If every time you have to hold a calculator and press stuff, that means it is a calculated value. So let's try calculating this. Be very careful when you're doing calculations. Please remember units. There's a kilo here. So this is really 1.25 times 10 to the 3 because of the kilo. Okay, so let's not worry about that. Let's try calculating that. So I usually recommend, if you have this type of calculator, you can do fractions like this, times 10 to the 3. This is usually the best way I recommend you to press your calculator. Okay, just do a fraction and use the power function on the calculator, which looks something like the one down here. Okay, let's see what we get. 1 over 1250. If your calculator shows this, change it to a fraction. If you're on the Casio series, press the SD. You get something like that. But second thing to be careful of is look at the unit over here. There's a prefix. So your first prefix here is kilo. Second prefix here is in a number form. So you need to remember that it's a number form. Luckily, let me show you a tip. Casio calculators, actually most of them can adjust the prefix for you. So you look for, on your calculator, look for the eng button, E-N-G. See this one right here? I'm trying to hover my mouse. Press the eng button. You see what happens? It's getting more and more negative. So you need to go in the other direction. So you press shift, eng. Oh, power negative 9. Okay, change again. Power negative 6. Oh, change again. Power negative 3. Yay, we have found the answer. So the eng button here, adjust the prefix on your calculator so you can, for convenience check and see. Okay, it only can do 3, 6, 9, 12. So you see now you have 0.8 times 10 to the negative 3. So let's write this down here. 0.8 10 to the negative 3 is already up there. So that's all. Now the SF, the important convention. Just now I said that you follow paper 3, right? If this is 3 SF, you can do 3 or 4. So if you are writing your convention here, what you can do is you write down this is 3 SF. How do I know? 1, 2, 5. 3 SF. Hence, this one on the right can be 3 or 4 SF. Which one you want to choose is really up to you. Okay, so let's say I choose 4 SF. Okay, I'm very extra. So 1, 2, 3, 4. I must write out all the zeros. Or you can just say 0.800 3 SF. Okay, so let's write this. Let me write it out down here. So you can do 3 SF or 4 SF. It's really up to you, but what I usually do, here's a tip. You're going to eventually plot this value, right? So if you go to the graph, this is what 1 over V. It's always helpful when you're plotting a graph to check what is the smallest you can plot. So you kind of zoom in all the way and ask yourself the question, how much is one box? One box is, what's the value? So you divide 1.7, this is what, 1.75. 7080. So you can say one box is 0.01. And that will give you an idea of how precise you need to be for your decimal place. So you check and see. Are you good to measure or to plot 0.01? Looks pretty good. 0.01. Yep, all this is fine. Okay, so it's helpful to check. If you're not sure, check your graph. Oh, I can plot. Okay, let's do the rest. So I'm going to calculate the second one again for you really slowly. You can fast forward this part. Once again, 1 over, what is this? 1.05. Please don't forget, times 10 to the 3 equal to, wow, SD. You can pretty much change the mode to decimal place so you can get something more readable. So I've chosen my eng, 0.9524. I think for this one, I will go with one extra SF, but I really don't need that much SF. So, okay lah, I will go with, since this is 3 SF, the minimum I can go is 3 SF for my value right there. And that will be, where's my device? Oh, I closed my calculator. Never mind. This will be 9.5. Sorry about that. 0.952. Or the alternate answer is 0.9524. Also can. Up to you. 0.9524. If actually during exam I need to write, I will probably just write this one because I only need a 0.01 precision for one box. See? I only need the 0.95 and I'm good because I will have to round off the 2. So it becomes 0.95 when I plot it. Okay? So over here I will plot 0.95. The 2 is rounded off. So yeah, just keep that in mind. Alright, so I'm just going to skip through and do the rest for you to see. But hold up, before we do that, there's something here to be careful of. This is only 2 SF. Oh, so you have to change your formula already. Because if this is 2 SF, this means you can either do 2 SF or 3 SF. Be careful, Okay, so you do the same thing, calculate, and you get these values, 1.11 or 1.1. Be very careful. Alright, let's do the rest. So I kind of shortcutted and wrote everything off. I did both as well. So the moral of the story is to be careful. For the first 2, it is only 3 SF. But for all these subsequent ones, it is 2 SF only. So that means for your table, these 2, the mark scheme will allow any answer that is either 3 or 4 SF. They'll be fine with that. And for all these ones, you must have either 2 or 3 SF. Don't go more than that. In fact, the mark scheme mentioned that a lot of people made that mistake. Okay, so be careful. SF to SF, raw calculated. This is how you can write out your table for almost everything except for the special case. So when you check the mark scheme, you will see that they give you a lot of possible values, 0.8 or 0.8000. Okay, so they show you all the possible. You want to jump between them is fine with me. Like if you want to do this for one and this for the next, it's fine. But why? Just stick to one. Unless you really don't want to plot that many decimals. So any of these answers will be fine. So you notice in the examiner report, they mention that the first 2 readings are 3 SF. But then the last 4 readings were 2 SF. And a lot of people did not realize that and did the mistake. So don't be that candidate, okay? Remember, here is 3 SF, 2 SF. And therefore, here can be 3 to 4 or 2 to 3. Okay, so that is the first idea of raw to calculated, just like paper 3. Now let's go to the special case. The special case appears when you have what we call log and ln numbers. Now this log and ln is actually a function that appears a lot in A2. What's a function? Okay, so you have trigonometry, right? Y equals to sine x. This is what we call a function. You press calculator, sine of some number, and then a number come out. You can also have y equals to log 10 of some number, x, and that's also a function. Or you can have y equals to log e x. Wow, what is this e? E is also a number. Or more commonly, this will be written as ln, natural log of x. Shortcut lah. Okay, so if you look at your calculator, you need to know how to press these numbers, right? So if you are looking for sine function, sine, cosine, tangent, so many. But if you want to do log, you can press log this log here, I guess. Some calculators have this. And you must type log base 10 of whatever number lah. That is how you can do log 10. Oh, sometimes they will shortcut and write this as LG. When you just see LG, that means it's log base 10. See? Log base 10, LG, okay? LN is log base E. Write this down if you don't take maths and you're like, wow, what is going on? Okay, never mind. So anyway, log 10 or LG will be this thing of whatever number. The log E function, you could do log to the, where is the E? Can you see E? Is this E? Your calculator should have E, and E is just this number, which we are lazy to write. So we just say E. Okay, done. So if you want to do log base E, you can do this, log E. The base is the small thing down there, and whatever number you want to calculate. But a shortcut is just to use ln. In fact, we won't write this at all. We'll just say ln in whatever equation. So ln, you should be able to find it on the calculator as well. If you look at this calculator, ln of whatever function number you throw in. So that's how you do log and ln values. Okay, so that is the end of this crash course of what is log and what is ln. Now, the interesting thing is they have a special SF convention. Let me write that for you to see. So if you look at this little statement here, for log quantities, is also a reminder from your lab manual as well. It's inside there. For log quantities, means anything that has log or ln, the calculated dp. Oh, interesting. Now the dp matters for calculated value. Calculated dp should follow the SF of raw figures. Okay, let me redraw the thing just now. Okay, so you have raw value, you have calculated value, right? Previously, in the normal case, we just say, oh, if this is 2SF, then this is 2 or 3SF, right? Normal case. Now, this special case is the one down here. If you have 2SF for your raw value, then this one should be 2 or 3 dp. Now, this is a special case I'm talking about. And this is for logarithms only. So anything log or ln. Okay, so there's a small example up there. If this is the raw value, where is it? Here. This is raw value. 3SF, okay, 3SF. Then after you do a log calculation on it, it should become 3 dp or 4 dp. And you round accordingly lah. Okay, so let's try out some examples here for this log or ln. Please write this down somewhere. Okay, the special case is very important. Write down somewhere, if not you'll forget. Alright, let's look at example from ON11 P52 Q2. Beautiful table, but full of logs. Look at this. LG means what? Log 10. So look at your calculator. Now, let's see what are we calculating. We have log. Let's do the first one. Log R stroke M. Now, why do they write this here? This is called the unit of the value that you are logging. So, log. The log itself has no unit. So, I write here, no unit. But the value that you are going to do the log of has a unit because that comes from here, ma. Okay, so this one is the unit of whatever you are feeding into the log. Okay, the unit of R lah, that you need to use for calculation. But the log itself, no unit. You see they didn't write unit outside, right? Okay. So if you write unit, make sure you put the slash inside the bracket. Okay, unit put inside there. Okay, let's do the first calculation. 129. How to calculate? Okay, first thing, highlight or circle all the prefixes so that you don't make a mistake. This is 10 to the power of 6. Please remember that. Okay, so we do take a calculator. Behind me, nice and big. Okay, what are we doing? Log LG. This one means log base 10. If they didn't write, means it's 10 lah. So you log base 10 of R. So we go. Do we have a log base 10? Okay, some calculators have this, so you have to type it out. But some calculators have the shortcut here. You see log. So if your calculator is this, you just press log. Easy. If not, you have to do this one and type the base. So mine is convenient, so I'm going to do this. Log of 129. That's this one. Don't forget the power. Just throw it in. Times 10 to the 6. Wow, so big. 8.110. Now, how many SF? How many DP? What is going on? let's write a reminder first. So if this is 3SF, 1, 2, 3. Now, special case, I need to follow DP. So this can be 3 or 4 DP. DP, yeah? You're following DP now. This is the special case. So if you look at your answer, should we do 3 DP? Yeah? Okay lah, 3 DP lah. 111, 8.111, round it off. So you write there, 8.111. Okay, don't worry about uncertainties for this. We'll do that in a second video. Okay, continue, do the rest, and you will get, yep, so this is the rest of it. And these are all the case where you have 3SF, so you should follow 3 DP, or 3 or 4 DP. Too many DP. Once again, best to check you see your graph. Okay, what is the smallest you can plot here? So you check and see. 6.2. What is one tiny little box? So you write there on your graph, one box is 0.02. So make sure your values can plot at least a precision of 0.02. So you check and see, 0.02. 0.02. Oh man, we've got to do some rounding. 0.02. Round to all even numbers. Okay, so looks good. Our graph is okay. We know we'll need to do some rounding work later to plot it. Now the last two, please be careful. These two, it's a bit sketchy. You know why? How many SF are these values here? If you look on the left side, all the way there. 1, 2, 3, 4. So this actually can be 4 SF, or you could also say, but miss, isn't this 3 SF since the 0 doesn't count? Yeah, lor, so we really don't know. This can be 3 or 4 SF. So there's a whole bunch of possible values you can do for this. Okay. So if that's 3 or 4 SF, means here you can do 3 or 4 or 5 SF, or 5 DP. Let's just write it, 3 to 5 DP. It's up to you. I wouldn't spend my time writing so many DP, because why would I do that? But you can just make sure you round them off correctly. So I'm super gung-ho and I just threw all the decimals there. So that's what I'll get for that. So let's do the same thing again for log T as well. Now let's use a different color, okay? So this one is now 2 SF. So you're going to follow what? 2 DP. So let's do this. 2 DP. Or 3. Round it off properly. And that is the same for these two values. So let's write it out. So that is other possible 4.37 something, but I'm just going to save time and write this now. Do a quick check. Can you plot 4.38 on your graph? Well, it's out of graph, but 0.02, so 0.02, 0.02. Okay, very good. Our precision is just right. No need to round some more. Very nice, I like. Okay, the last few, you got to be a little bit more careful, because now here is 3. It's a controversial one again. So these two are 3 DP, 3 SF. This one is 2 or 3 SF. See, so many possible answers, right? This one is 3 or 4 SF. Up to you. As long as you write any of the correct answers, you should be fine. So let's write all the possible answers. There's all the values. So let's make it a little bigger so we can see. So for these guys over here, this is following our 3 SF. So this can be 3 to 4 DP. DP for special case. This is a weird case here. So this one can be, this one here, 2 or 3 SF. Means you can be 2 DP or 3 DP or 4 DP. Quite a big possible range. Okay. The next one, 3 or 4 SF. So it can be 3 to 2, 3, 4. 3, 4, 5. Oh my goodness. 5 DP. So many possible. 5 DP is a bit extra. Please don't go there lah. So many decimal for what? Later have to round until like crazy. So this is how you can complete a log table. Just remember, be careful to check the units, especially prefixes. Underline them. Draw circles on them whenever you see them in papers. And logs. Remember, if you see LG, it means log 10. That's the main thing to tell you. Okay. So if you look at the mark scheme, they'll be like, you got so many possible answers, they just write for you a few examples. So you got any of these or even a little bit more, it's okay one lah. Okay, so just make sure you know how to round them off. And they allow a mixture of decimal places because they know it's a bit all over the place. But minimum 2 dp for these guys right here, because you need to plot a graph and your axis must have a precision of 0.02, or you must have precision of 0.02 in order to plot nicely. So sure, if you round wrongly, they're just like, whatever lah. We know it's been a long day. It's okay if you plot wrongly. So do check out the mark schemes for some of these. But remember how to calculate logs and lons. This applies to that. So to summarize what we did today, here's a general reminder. Once again, you have raw values and you do some calculation on them. The moment you hold a calculator in your hand, you are dealing with a calculated value. Think of it this way. Okay, so raw becomes calculated. If it's all mostly all kinds of calculations, like just use a paper tree convention. So if you, for example, voltage, calculate become 1 over V, or I don't know lah, V square, or what else we want to calculate, square root of VI. All is like considered normal. So you are going to do something like this. You have whatever SF. So if this is 3 SF, you can do 3 or plus 1, which is 4 SF. Apply this SF to SF. Let me draw a box for you. Same or plus 1, no? Same is 3 and 3. Plus 1 is 3 and 4. Now, you have special case only for logs, logarithmics, natural logs, which is new. So if you have something like V and you're doing log V, or I don't know, ln of V, all kind of things lah, then you need to be very careful because now you are doing what we say 3 SF, but you are doing 3 or 4 dp. Wow, we follow dp now. Do you see the difference? Please write this down. Here is SF to SF. Now it's SF to dp. Only for special cases. Okay, so that's all. If you're curious to learn more, why is this true? Ask a teacher or go Google, okay? But you don't need to know the why. You just need to know the convention, okay? So that is all for this video. Hopefully that is helpful in getting you to write your tables properly. Conventions, units, know how to write the units for log, how to do your SF DPs, and write reminders for yourself, or you will keep on forgetting and keep on asking your teacher how to do these calculations, okay? So that's all for this SFDP. Go on to the next one and we'll look at how to calculate uncertainties to get ready for graphs. See you in the next video.